Hello, class. So we are section 3.3 now, which is about division of polynomials. Okay, so we're going to talk about dividing polynomials. This is probably my personal favorite section, just because I don't know, I like it. But first, before we talk about division of polynomials, I want you guys to remember how to divide numbers. Okay, specifically, I want you to remember how to long divide. Okay, so it might have been a while since you've done this. Okay, but if you remember, what you do is, right, you look at this number and you're like, what times this number gets me close to 4, right? And you're like, 2 is 6, that's too big, so you have to put a 1 here, right? And then you do 1 times 3 is 3, and then you subtract, right? Get 1, and then this falls down, and 17. And then you do it all over again, right? So you're like, what times 3 gets me close to 17? 5, right? And then 5 times 3 is 15. Then you subtract and you get 2. And then 2 is smaller than 3. So maybe, depending on what grade you are, you would put like a little R2, right? So hopefully you remember how to do that, okay? Because we're going to need that. So I'm going to talk about what's called the division algorithm right now, okay? And what the division algorithm is one way to write multidivision, okay? So 47, right, we just figured out 3 times 15, but not exactly, right? You have to do plus 2. And this is what like the division algorithm spits out. Okay, so you have your divisor, right? Divisor, quotient plus remainder, right? So divisor, quotient, remainder. All right, now I'm gonna just directly go and be like, look, it's the same thing. Okay, just if I have a polynomial, it would be a dividing polynomial with a quotient polynomial and a remainder polynomial. Okay, so it's literally the same formula, just with x. Okay, and we're gonna do the same thing. But like disclaimer that the degree of the remainder has to be less than the degree of the divisor. Okay, because that's how we know, like, right? 2 is smaller than 3, so we know to stop. With polynomials, it would be Rx has degree less than D, so that's when we know to stop. Okay? So, example 1. Okay, I'm going to have 6x squared minus 26x plus 12 divided by x minus 4. Okay, so we set this up in the long division thing. Okay, so x minus 4 goes here because that's what we're dividing. 6x squared minus 26x plus 12 goes in there. And so we do the same thing, okay? It's just really we only care about the x, okay? This minus 4 is just gonna tag along for the ride, okay? So you ask yourself, x, what times x gets me 6x squared? Okay? And you go and you're like 6x, okay? And then just like long division, you do this thing times this thing, which that's going to be 6x squared minus, and then 4 times 6 is 24 x. Okay, so you see how like I foiled it, right? Or distributed. Okay. And then what I like to do is I like to put a minus here, and then I subtract, okay? So 6x squared minus 6x squared, that's 0, because that's what we wanted. And then you go negative 26x, right? minus negative 24. So that's a double minus. So it's a plus. So then you're going to get minus 2x. And then the 12 just falls down. Okay? So if you understood that, then you're good. You basically understand the whole section. If you don't, then we're about to do it again. So let's go. Okay? So now we have a minus 2x and x. So what times x gets you minus 2x? And the answer is, I mean, I hope it's easy. Right? It's minus 2. So then you multiply minus 2 by this thing. Okay? And you're going to get minus 2x plus 8. Right? Yes. And then I'm going to put the extra, subtract. You're going to get 0 because that's the point. And you're going to get 8 minus 12. I mean 12 minus 8, which is going to be 4. And then x does not go into 4, right? So the remainder, right, the remainder is 4. So now we can stick this in the division algorithm. So we get 6x squared minus 26x plus 12 equals x minus 4 times 6x minus 2, and then the remainder plus 4. And ta-da, this is sort of the answer. Technically, this is not the answer. This is the division algorithm. If I asked you this very specifically, the answer to the question would be, so let me write it kind of more like normal, right? I would normally do it like that with the fraction bar, not with the divide symbol. Okay? And then technically, kind of like if you remember, it would equal 6x minus 2, and then plus 4, and then you divide by this thingy, right? So kind of like regular, maybe the thing you learn to do after you put the little R2, right? Here you would maybe sometimes put 2 over 3, right? So yeah, this would technically be the answer, but I like the top one more. Okay, now let's do this again, just in case you don't get it. All right, this is basically almost the whole section. Is can we divide? Okay, so now I'm gonna divide. Okay, so I want to know 8x to the 4th power plus 6x squared minus 3x plus 1. And I want to divide that with 2x squared minus x plus 2. Okay, so slightly longer, slightly bigger. Okay, so 2x squared minus x plus 2, 8x to the 4th plus, and so a big deal, guys, something to notice, is that x cubed is missing, right? There is no x cubed term. And like a pro tip is if you're missing like terms, I would definitely advise just put a 0x cubed there before you like accidentally make a sloppy mistake, okay? So then 6x squared minus 3x plus 1. Okay. And then so again, we only really care about the leading term, okay? These two are just gonna tag along for the ride, okay? But so what times 2x squared would get me an 8x to the 4th? So hopefully the x squared part is easy, right? X squared times x squared is x to the 4th. And then 4, right? 4 times 2 is 8. So there we go. So 4x squared. So then I'm going to multiply this by all of this, okay? So we're going to get an 8x to the 4th, and then minus 4x cubed plus 8x squared. Okay, and then I'm going to subtract the whole thing. So you're going to get 0 here, because that's the point. Okay, so I'm not even going to write the 0. but you're gonna get 0 here minus 4x cubed, so you're gonna get plus 4x cubed. And then 6 minus 8, that's gonna get you negative 2x squared. And then both of these just fall down. Okay, so step 1 done. I mean, the 1 doesn't have to fall down, I guess, but step 1 done. Okay, now we do it all over again. What times 2x squared gets me 4x cubed? That's 2x, hopefully. Okay, so then you're gonna get 4x cubed plus 2x squared plus 4x. And then I'm going to put the minus sign. That's 0, 2 minus. Oh, wait, no. Negative 2 squared minus 2x squared. That gets you negative 4. And then 3 minus 4, that gets you negative 7. Excuse me, wait. 2x times this thing, excuse me, that will get you a minus here. Okay, I know for those of you that were wondering, why is it a plus now? That was wrong. Okay, so you get a minus. So then actually this cancels, which is nice. That's very pretty. Okay. And now the 1 falls down. All right. And then we're done. Right? Because this has degree 1, but this has degree 2, right? So officially we're smaller than what we're dividing by. So that's the remainder. So the answer is 8x to the 4th plus 6x squared minus 3x plus 1. Okay, that's going to be equal to the 2x squared minus x plus 2 times 4x squared plus 2x. Okay, and then plus remainder. So this. All right. Okay. All right, so that's long division. I hope you understand it. It's pretty important. Okay. Now I'm going to show you something that is shorter. Okay. It's better. Okay, and it's called synthetic division. Okay, so I'm just gonna compare the two here, actually. Okay, so I'm gonna long divide 2 x minus 2 and then this cubic. So plus 0x plus 5. Okay. So let's long divide one more time. Okay, so I'm gonna get a 2x squared. So that's gonna give me 2x cubed minus 4x squared. So I'm gonna subtract. That's gonna get me a minus 3x squared. I'm gonna drop these down. Okay, so then I'm gonna want minus 3x. So minus 3x squared plus 6x. That's gonna get me negative 6 plus 5. And then that obviously, then I want a minus 6. So minus 6x plus 12. I'm gonna subtract, and then I'm gonna get a negative 7. Okay, which is the remainder. So then I'm done, right? I could finish it, like write the division algorithm and ta-da. Okay. Now that's this is kind of long, right? Like I know exactly what I'm doing, and it still took like this much space, right? And it was, I don't know, maybe like a minute, right? So here I'm going to introduce the synthetic division. Okay. So what you do is, right, I'm dividing by x minus 2. So I flip the sign, and I'm actually going to use the number 2, okay? And then I write down the coefficients. Okay, so it's going to be 2, negative 7, 0, 5. Okay, so I write down the coefficients. Then I do this like algorithm, okay? So the first number always just falls down, and it's okay, it just goes down. Then you do 2 times this number, and you put it here. Then you add these. So -7 plus 4 is -3, okay? Then you're going to do 2 times -3 and get -6. And then you're going to add them. So you're going to get -6. And then lastly, you're going to do 2 times -6 and get -12. Then you're going to add them, and you're going to get -7. Okay, and the last number is special because the last number is your remainder, right? Look, -7, -7. Okay? And in fact, these coefficients are special because if you notice, they're the coefficients of our answer. Okay, so if you do synthetic division, as long as you know what it means, it's way faster. Okay, so from here you can see, right, x minus, okay, so I guess I should write it down. I should write down the answer. So 2x cubed minus 7x squared plus 5 is equal to x minus 2. And then from here, you always just go down by 1 power. Okay, so right, this is 3. So it's going to be 2x squared minus 3x minus 6. And right, and then this would be minus 7. Okay. Or I guess more properly, x minus 2. And then it makes a little more sense because it kind of keeps going down. So right, this is like a negative power. Okay. All right. Okay, so let's do some more synthetic dividing. Okay, so I want to divide 5x to the 5th plus 3x cubed minus 2x squared plus x. I want to divide this by x plus 1. Okay, so I want to do synthetic division this time. So -1, okay, remember, I'm switching signs, okay? So if I want to divide by x plus 1, I actually synthetic divide by -1. And then I write down the coefficients. So 5. Okay, this is a huge deal because you cannot catch yourself in synthetic division. All right. You have to put the 0 here or else you're just it's gonna be wrong. Okay. So with long division, if you were smart, you could probably survive without the 0 because the x's are there. So if you did math correctly, it'll still work out. Here, you need to put the zeros, okay? So 3, -2, 1, and right, there's no constant, so another 0, okay? All right, and then the 5 falls down. 5 times -1, -5, -5, 5. That's 8, -8, -10, 10, 11, 11, -11, just kidding, sorry. So -11. All right, so the remainder is -11. All right. But now I want to do something interesting, okay? So this is a good segue. So 5x to the 5th, if I do the division algorithm. 5th? 5th. Yeah. 5x to the 5th plus 3x cubed minus 2x squared plus x equals x plus 1. My answer, so 4x to the 4th minus 5x cubed plus 8x squared minus 10x plus 11, and then remainder is -11. Okay. Now, what I find a lot of students do is they don't really like understand that the equal sign really does work both ways. Okay, so I'm gonna ask the question, okay, with this polynomial here. What happens if I plug in -1? Right? So you guys can figure that out, right? You can plug in -1. It's not even that hard, right? You just do this and like get an answer, right? Okay, but a fancy thing to do, okay, which computers like, is right, if I plug in -1 and I look at this thing, I'm gonna get -1 plus 1 here, right? Which is actually 0. So then it doesn't matter what this is. Like, I don't have to think about it because this is a 0. So the answer actually is, so if this is f of -1 is actually just -11. It's the remainder, okay? So this fancy fact, all right, this useful thing, it's actually called the remainder theorem. All right, so the remainder theorem is basically if you have a polynomial and you factor out an x minus c, okay? Well, just let me kind of, if you plug in the c, right, you get c minus c, dc plus rc. That's 0. So the answer is just the remainder, okay? So this is one way you can plug in numbers, okay, fast. So, for example, if I gave you a polynomial, that's like 3x to the 5th plus 5x to the 4th minus 4x cubed plus 7x plus 3, right? And I asked you, like, plug in -2, okay? So if I want to plug in -2, you could do it. It would just be like, right, it would be annoying. You'd want a calculator, right? Because that's like a lot of math you have to do, right? One thing you could do, though, is synthetic divide by -2, okay? So 5, 4, 3, 2, yeah, okay. So if we synthetic divide, then it's, much less painful. So, 2, that gets me -2, which that gets me 4, which that gets me, wait, what? Oh, see, okay, yes. I even double checked. No x squared, okay? So 0, 7, 3, okay, big deal. So 4, 4, -8, -1, 2, 5. All right. So, right, the answer is p of -2 is 5. Okay, by the remainder theorem. Okay, and you could plug it in, right? Like if you really wanted to, it would be 3 and then -2 to the 5th plus 5 -2 to the 4th minus 4 -2 cubed plus 7 -2, right? And then you could be like 3 times 32, -32, plus 5 times 16 minus 8 times -8 plus minus 14 plus 3. And right, you could just keep working this out and you'll get 5. Okay? So this is a much better way to plug in numbers into polynomials. Okay? So let's do one more example of this. Okay, and you'll see something interesting. So here I'm going to have a polynomial, x cubed minus 7x plus 6. Okay? So first of all, I want you to look at the polynomial and notice that right now, if I asked you, like, solve this, right now you can't, right? Because you can't factor this by grouping. and it doesn't factor into like, you know, something like this, right? You guys don't know how to factor cubics. So right now you don't know how to solve this, okay? But I'm just gonna randomly ask you the question, what's P of 1? So you would synthetically divide by 1. So let me put the 0 in the right spot, okay? So let's do some synthetic division. 1, 1, 1, 1, -6, -6, 0. Okay? Wait, so that means P of 1 is 0. So 1 is a 0. Okay? But that also means, right, if I do the division algorithm thing, so x cubed minus 7x plus 6 is equal to x minus 1 times this thing. So x squared plus x minus 6 plus remainder, but the remainder is 0. So you've actually factored. Okay? And this is how you solve things that are bigger than quadratics, x squared things, okay? Is you're gonna synthetic divide by the zeros and just factor them out like one at a time. Okay, because now if you stare at this, right, you know how to factor that, right? That's x plus 3, x minus 2. And ta-da, now you've fully factored the polynomial, right? And you know P's zeros are 1, -3, and 2. Okay, which before right now you would have no idea how to find these zeros. But with the power of synthetic division, you've been able to fully factor it. Okay, so this is called, okay, this useful factoid is called the factor theorem. Okay, so the factor theorem says C is a 0, okay, if and only if x minus C is a factor. Okay. So, useful. All right, let's see if we could do another example. Okay, so now I can ask you questions like this, and this is really kind of the next section, but let me just kind of just use the power of synthetic division. Okay, so if I have this thing and I want you to tell me, like, what are the zeros? Like, what are P of X's zeros? Okay, well, you know you can't factor it, and it's not a special formula, so you're kind of stuck, right? And in the next section, I'll teach you how to know what numbers to guess. But for right now, I'm just going to tell you 1. Guess 1 is a 0, okay? So I'm going to synthetic divide by the number 1, and let's see what happens, okay? So 1, 1, 1, 1, -2, -2, 0. So it works. And in fact, P of x now is equal to x minus 1 times x squared plus x minus 2. And then as soon as you get here, right now, you can solve this no matter what, right? You can slap that in the quadratic formula. You can complete the square. But here it actually just factors again into something nice. Oh, so actually, -1 had multiplicity too. Okay. So the zeros are +1, excuse me, are 1, multiplicity 2, and -2. All right. And it's synthetic division that really allows us to get there. All right. Now, last thing in this section. All right. It might be a homework question. It's not really a big deal, but you need to be able to kind of go backwards. Okay. So this is how, for instance, I make test questions or homework questions. Okay. Is I have to ask myself, find a polynomial. Okay. Find a polynomial of, and then degree whatever. So I'm going to choose degree 4. Okay. Such that it has zeros 1, -2, 0, and 3. Okay. So just make a polynomial that has those zeros and is degree 4. Okay. Well, what you do is you kind of just write the factored version. So write x minus 1, x plus 2, x minus 0, I guess, and then x minus 3, right? These all correspond to a 0, right? So this has all of the zeros we need. And if you FOIL it out, you will see that it's degree 4. So let me actually FOIL it out. So I'm going to get x squared plus x plus 2. And then from here, it's going to be x squared minus 3x. And then I'm going to actually have to FOIL this the long way. So x to the 4th plus x cubed plus 2x squared. And then minus 3x cubed minus 3x squared minus 6x. So if I do that, the answer is x to the 4th minus 2x cubed minus x squared minus 6x. And ta-da, there's the answer. This is the polynomial of degree 4 that has these zeros, okay? And then now I erase all of this work and then I just ask you guys the question, factor this or find all of the zeros, right? So really, this is what I have to do to make test questions, homework questions, all that kind of stuff, okay? Is you answer the question, make a polynomial that has these specific zeros. And you start off with it factored, and you actually have to FOIL it out and get the answer, okay? But this is like really not important, okay? It's maybe you get one homework question about this, but that's it. All right. That's it for section 3.3. All right. Learn long division, learn synthetic division. Okay, that's the point of this section. Is know how to do long division, and then definitely 100% you need synthetic division because it's how we're gonna solve polynomials in the future. Okay. So that's it, and I'll see you guys next time.